Okay, so today we're going to do some standard trigonometry and we're going to introduce the unit circle. No more funny Fortnite stuff, maybe later. But this was originally suggested to me by a friend. Emma, you know who you are. Um, and I hope she, along with a lot of people, find this video useful. And if you don't know anything, please comment below. I will try and read those answers and I will respond to you. So before I do that, let's do some recalling. Okay, so obviously this is trigonometry. You're gonna recall SOHCAHTOA. And these are just your trig functions. This is sine, this is cosine, this is tangent. So these are just ratios. Ratios where the angle of that right triangle has with the opposite and the hypotenuse. This means that if I have a right triangle, for example, it's a bad triangle, I'm sorry, theta, sine of this angle theta would be this side, opposite side, as a ratio on the hypotenuse. Same thing with cosine, but for the adjacent side, which would be this side and the hypotenuse. Tangent would just be this opposite over adjacent. Another thing you need to recall is your special right triangles. Okay, so these triangles are special for like a lot of reasons. The first one is the 45-45-90 triangle. And the unique thing about this one is that since this is an isosceles triangle, because these two angles have to be the same if this one is 90, this side and this side is the same. That's just standard how isosceles triangles work. So let's just label this side x. So that's a bad x. This side also x. Right? This side would be x squared plus x squared all over root 2. So let me put that in black. This pen is kind of bad. X squared plus x squared all square rooted. This is the same as saying 2x squared, because they're doing two of them, square rooted. Split the radical. This x squared would become x. Square root of 2 would just become 2. So this side would be x root 2. Right? If this side is x, this side is also x. This is the 45-45 one. The next one is the 30-60-90 triangle. 30, 60, no, this is the wrong one, my bad. Flip it around. 60, 30, 90. This comes when you bisect equilateral triangle with each angles of 60. When you dissect this angle 60 into 2 halves, you get 30. So if this side are all the same and these sides are split into two good parts, this one side is going to be half of what this is. So let me name this one side x, and since this was half of that, this would be 2x, because it's double the size. That's what half is. You can use Pythagorean theorem to figure this one out. This would be 2x squared minus 2 squared x squared. My bad. This is going to be 4x squared, because you're squaring the x too. Squaring the 2, my bad. X squared, all square rooted. 4x squared minus x squared is 3x squared. And you do the same thing over here. You're going to get 3 square root of 3 times x. So this is x root 3. This, what these numbers really mean is how much of a factor x is increasing by. So this 2x means that that x, the smaller side, the hypotenuse is double the smaller side. And same thing here, this root 3 means it is root 3 times the smaller side. Also, one more thing is radians. It's just a degree of measure. So for every 180 degrees, you would have pi radians. Same thing for like every like 1.9 kilometers, you would have 1 mile. For every 180 degrees, you would have pi radians. And what is 1 radian? It's basically how many radiuses of a circle you would take to go to that angle. So for example, going 1 full circle, you would do 2 pi radiuses or radii, because the area of a circle is 2 pi r. So this entire circle angle would be 2 pi radians. Half of that would be pi radians, because you take pi radiuses to go the entire half the circle. So just a little note is that 180 degrees is equal to pi radians, 360 degrees is 2 pi, 90 is pi over 2, 60 is pi over 3, 30 would be pi over 6, because you're doing 6, it makes sense because you're basically dividing the entire thing by 4, because 360 divided by 4, right? And the 45 would be pi over 4. So, and the way to convert between the two is, if you're in radians, you would multiply by 180 over pi, and if in degrees, you would multiply by the inverse, which is 100 pi over 180. This is what you would do when you to convert. So degrees, radians. So now we're gonna to start the actual thing. Instead of recalling, we're gonna actually look at this circle. Because this circle is really interesting. This is what we call the unit circle. Why unit? Because its radius is length 1. This radius is length 1 over here. Now, I'm going to do something special. Also, I want to recall this equation of this radius is x squared plus y squared equals 1. That's just your standard equation for a circle. But in this case, this is what it is. So, I'm going to take a random point here, and I'm going to draw a parallel down, and I'm going to connect the origin with the dot again. And one thing you notice, this is obviously a right triangle, and I'm going to call the angle between the origin and the hypotenuse as theta. It's a 0, theta. Now, what are some observations we can make? Observation. One thing is, the hypotenuse has to be equal to 1, because this is the radius. This hypotenuse is 1. Secondly, is what is the length of the legs, aka these sides right here? Let's use some trigonometry. So we know that the cosine of this angle would have to be this adjacent side over 1. But wait, the adjacent side is just the x direction of that given point, this point right here, because you're going that much horizontal. Similarly, for the y direction, this thing, you're going that much up, and that is also, that over 1 is your sine, aka the legs of each other are the cosine and sine respectively. So the cosine of x is equal to the x coordinate of the point. X coordinate of point. Similarly, sine of theta would be the y coordinate of the point. Because of this radius being 1. Okay, so what are some things that I can make from that? One thing I can say is that, first off, before we were limited between 0 and 90 because you couldn't have any other angles in a right triangle between above 0 and 90. But now we can, because all you have to do is just rotate this unit circle, get a new x coordinate, and then find your new cosine. Another thing we can say is we can pull some identities, aka some useful formulas that can help us in solving stuff. Since I know the x is the cosine, and since I know the y is the sine of this angle, I can say that cosine squared of any angle plus sine squared of any angle has to equal 1. Because of two reasons. A, I'm substituting this x for this, because this is the x coordinate for the entire circle, and the y coordinate for the entire circle. Also, this is just the Pythagorean theorem, because we know that this side is sine theta. We know that this side is cosine theta. So we can square both sides, and that would equal 1 squared, which is just 1. So it's perfect. We have a new identity to use. So, okay, so now we're gonna do some graphing of these functions. So now that since we can expand the domain to any number now, because you can keep on rotating the circle and getting bigger and bigger angles or smaller and smaller angles, you can go negative too. I'm gonna try and start graphing this function, similar to how I graph linear functions or quadratics. So let's start with this. Let me start with the simple old graph. Okay, I'm gonna start with sine. Let's start with sine because it doesn't have a c in front of it. I don't know. Yeah. When sine's at 0, it looks like this, because remember, sine is just the length of this vertical leg. When we're at 0 degrees, sine is at 0 degrees because there is no vertical length. So we know that sine has to be 0 when theta is also 0. Okay, let's move this to pi over 2, aka 90 degrees. When it's 90 degrees, sine being the vertical length is the entire radius, which is 1. So let me name this pi over 2. Remember, that's just 90 degrees, don't get confused. Is just 1. Okay, let me move this thing to pi, which is just 180 degrees. When I go back this way, the vertical height of the leg, right? For example, this is a triangle on the other side. Sorry for the squiggly lines. This vertical height on this side now is also 0. So at pi, sine is at 0. Now we can rotate again to this side, and this side, sine, is the entire length again. But this time we're going downward. This is -1. Remember, we're not looking at the absolute value of the leg, we're just looking at the x of the y coordinate, which is just -1. So this time we're going downwards. So let me extend this graph right here. This is 3 pi over 2, aka 270 degrees. Remember, pi over 2 is 90 degrees, and you're adding 3 of them to get 270, and pi over 2 added 3 times is 3 pi over 2. 1/2 plus 1/2 plus 1/2. Okay, let's go to 360, which is 2 pi. We're back at the same place when we started, 0. So that means it's the same x, y coordinate. Sine of theta is also the same as it was at 0. So does that get 0? So at 2 pi, we're at 0. Now one thing I noticed is you're going to keep on rotating it forever and ever, but it's going to keep on going at the same points. Because in reality, 0 radians and 2 pi radians is the same as 0 and 360 degrees are the same angle. You're just going in a circle one extra time. So this thing is going to repeat on forever, having a period of 2 pi, aka one slice of it is going to look the same every 2 pi, and it's going to repeat the same structure every 2 pi times. So let's connect this thing. This looks like it's going to go curving like this, right? Because it's not going to go linearly. It's going to like this, like this, like this. Look, we have a wave, and we can extend this because we know it's going to oscillate. That's what sine looks like. Let's do cosine. At 0, what is cosine? Well, cosine is just the horizontal component of the triangle. This horizontal component, when it's at 0, is 1. When we're at 90, or pi over 2, the horizontal component is 0. There is no length, because it's a straight line upwards. So we're at 0 now. What about this length over here? Can you guess? It's -1, not 1. Why? Because we're looking at the x-coordinate, which is -1. So we're going down -1. That's at pi. Let's look at the pi over 2, which is 270 degrees. This one. What is the x-coordinate? It's 0. Because there is no horizontal length between the origin and that point. And then we can go back to 2 pi, which is the same as this point right here, because you're going in one circle and you're back in the same spot. You're back up here. Since we know that they're going to increase and decrease the same way as the sine function, right? It's going to like slowly increase and then slowly back down. We can connect the same way by using a wave. This is your cosine graph and your sine graph. And this is how it's going to look like. Alright, let's make some observations about this graph now. We said one thing is that it repeats every 2 pi. It's never greater than 1. Greater than 1. 1, likewise, never less than 1. Sorry, not less than 1. -1. But what if I want to do that though? Obviously, you can do your standard shifts that you learned in other functions. You can add the whole thing by 2. And obviously, if you add the whole thing by 2, all this will shift vertical upwards plus 2. If you add the variable of input, so if you make this cosine of theta plus 2, all of this would shift. It would shift this way because it's opposite. For horizontal, it's really weird if you think, but you have to think about it that way. It's going to shift -2 that way. What if I multiply this entire cosine graph by a constant 2? Say 2. This one, I'm going to get 1 over here, and this 1 is going to be multiplied by 2, and it's going to go 2 over here. Likewise, this -1 is going to go to -1 over here. This 0 is going to stay at 0. But this one is also going to go to -1 over here. AKA, let me put this in red so it doesn't look so confusing. Oh, I just missed that 0 so badly. My bad. Let me fix that. It's going to stretch. And I can see that's pretty much it for sinusoidal functions. Please comment anything that you need for help. And I will see you later.